Hi everyone, today, I'm thrilled to introduce something I've been building from the ground up, an AI agent harness called Medhavi. What makes this project exciting is that it's designed to deliver intelligent agentic capabilities at near zero operational cost, making advanced AI orchestration more accessible and scalable. Medhavi is currently an active research project, and this is only its first milestone. The vision is much bigger, and I'll continue expanding and refining the platform over time. For today, I'd like to demonstrate the core features already implemented, share the thought process behind the architecture, and give you a glimpse into where this project is heading next. So, let's dive in. Now, let me walk you through the UI of Medhavi and some of the key features currently implemented. As you can see, the platform supports multiple themes, including a full dark mode experience for better usability and personalization. On the bottom section, users can dynamically select the AI model they want to interact with, making the platform flexible and model agnostic. We also have a secure developer mode access mechanism. During the initial setup, an admin code needs to be configured. After that, authorized users can use the same code to unlock the developer interface. Once developer mode is enabled, several advanced diagnostic and orchestration panels become visible. These sections provide deep transparency into how Medhavi is operating internally. For example, you can monitor what Medhavi is currently planning to do, the execution flow being generated, which tools are being invoked, whether it is calling a RAG pipeline, whether it is using a predefined skill, and how the agent is reasoning and orchestrating tasks behind the scenes. The goal here is not just to build an AI assistant, but to build an observable and controllable agent system, where developers can clearly understand the decision-making process of the AI. This becomes extremely useful for debugging, optimization, research experimentation, and future extensibility. Now, let's see how Medhavi behaves during a normal conversation. One of the key capabilities I want to demonstrate here is the agent state memory that Medhavi is able to persist across interactions. This allows the system to retain conversational context and remember information shared earlier in the session, making the interaction feel much more natural and intelligent. For example, once I tell Medhavi my name, it is able to remember and use that information throughout the conversation without needing me to repeat it again and again. Next, I'd like to demonstrate the real-time web search capability of Medhavi. Let me ask something related to a current event, for example, the ongoing Indian Premier League 2026, and let's observe how the system behaves. As the request is being processed, you can notice activity appearing in the side panels. These panels essentially provide visibility into what Medhavi is thinking, how it is planning the execution flow, which tools are being triggered, and how the agent is orchestrating the response internally. This level of transparency is incredibly valuable because it allows us to observe the reasoning pipeline in real time instead of treating the AI as a black box. And now, look at the response generated by Medhavi, structured beautifully in a clean tabular format with real-time information retrieval. Pretty awesome, right? Well done, Medhavi. Now, I'm going to demonstrate another very important capability of Medhavi, its intelligent caching mechanism. As we know, every time an agent performs a live web search using providers like Tavily, it incurs additional API cost. So, repeatedly fetching the same information is not only inefficient, but also expensive at scale. Now watch this carefully. I'm asking Medhavi for the same information again. Here, you can already see in the thinking panel that the agent has detected this as a previously answered query. Instead of triggering another external web search, it intelligently retrieves the response from cache. You can also observe this behavior reflected directly in the response pipeline. So essentially, no unnecessary external API call was made. Response latency was reduced, and we saved some money on search costs as well. This becomes extremely powerful in large-scale agent systems where optimization, latency, and operational cost matter a lot. Pretty cool feature, right? Now, I'm going to demonstrate Medhavi's MCP integration capability. For this demo, I've exposed a simple MCP tool to Medhavi that performs a basic addition of two numbers. As soon as I ask the question, you can observe that Medhavi immediately recognizes that this task should be handled through a tool invocation rather than generating a direct LLM response. If you look closely at the side panels, you can clearly see the agent's thinking process, the execution planning, and the actual tool call being triggered in real time. Once the MCP tool returns the result, Medhavi uses that response to generate the final answer. This demonstrates that Medhavi is not limited to built-in capabilities. It can dynamically integrate with external systems and tools through the Model Context Protocol (MCP) architecture. Which means, theoretically, Medhavi can be connected to virtually any MCP-compatible service available on the web, enabling powerful extensibility and real-world automation use cases. That's the real power of an agentic system. Now, let's move on to another exciting capability of Medhavi, its RAG integration, which stands for Retrieval Augmented Generation. For this demo, I'm going to show how Medhavi can analyze an online blog or external knowledge source and intelligently answer questions based on that content. Instead of relying only on the LLM's pre-trained knowledge, Medhavi first retrieves relevant information from the provided source, processes it, and then generates context-aware responses. This makes the responses far more accurate, grounded, and domain-specific. Now, let's see how Medhavi reacts when I provide it with an online blog to analyze. As you observe the side panels, you'll notice the agent planning the workflow, fetching the content, processing the retrieved data, and then generating the final response using the RAG pipeline. And there it goes. Go Medhavi, rock it! Last but not the least, the final feature I want to demonstrate today is the coding capability of Medhavi, specifically, how effectively it can analyze real-world software projects. For this demo, I already have a project repository cloned locally. Now, I'm going to ask Medhavi to analyze the entire codebase and generate a high-level summary of the project. At this point, we'll give the agent a few moments to process the repository and analyze the files. What's interesting here is what's happening under the hood. Medhavi is leveraging a skill-based execution framework, similar to the concept used in Claude code, where specialized skills can be invoked for complex workflows like code analysis, repository understanding, debugging, and code generation. And the exciting part is, you simply need to define a skill file, and Medhavi can orchestrate highly powerful workflows around it. That means developers can extend the platform rapidly with custom capabilities without modifying the core agent architecture itself. Now you can see the result. Medhavi has beautifully analyzed the repository and generated a structured, human-readable summary of the entire project. Beyond analysis, it can also generate code, suggest improvements, identify bugs, and even help automate fixes when required. And with that, this concludes the demo for the first milestone of Medhavi. This is only the beginning. I'll continue improving the platform, adding more advanced capabilities, and evolving it into a more powerful and intelligent agent ecosystem over time. Thank you so much for your time and attention. Have a wonderful day ahead.